In this video, we'll go over the homework that follows the second part of the lecture covering the absolute convergence tests. And in this one, we discussed the root test. And as always, I hope that you watched the lecture before attempting the homework. And let's go ahead and jump right into the homework. So the first question here is to analyze the convergence of the given series, and normally we would ask whether it's we would try to see if it's a geometric or p-series first, and then we would try to set up the divergence test. But when the limit is hard to find, we will just bypass this step and start doing the convergence tests. And in this case, we are doing the root test. So let's make a habit of declaring what test we are doing. And to set up the root test, we set up the following limit. We take the nth root of the nth term, and to take the nth root is the same as raised to the power 1 over n. So it's the same as doing this. Now we can simplify this expression further. And this one there is a pattern that you probably want to remember here. 1 plus 1 over n to the power n approaches to e. So, but instead of n, you can have anything. So if you have 7 over n here, then just put over 7 here. And if you have minus here, then just put minus there. And with that in mind, this is our thought bubble. With that in mind, I'm going to rewrite this as 1 minus 7 over n to the power negative n over 7. But I don't have negative n over 7, I have n. So that means I have to raise everything to the power negative 7 to kind of produce an equivalent expression. And now what's inside of the parentheses is actually converges to e, and therefore the whole thing converges to e to the power negative 7, which is definitely less than 1. So by the root test, this series converges absolutely. I guess that's actually interesting. Like the pattern, the way that Newton presented it, is kind of also makes it nice. So 1 plus k over n to the power n converges to e to the power k. That's the same result as I showed you, but in a nicer form. So let's move on. We have another root test. Normally we would check if it's a geometric or p-series. Then we will try to set up the divergence test. And if finding this limit is too complicated, then we would bypass this step. Here we are asked to use the root test, so let's go ahead and do the root test. We're going to set up the limit as n goes to infinity of the nth root of the general term. But in this case, you can see how the nth root of the general term just cancels the nth power, and we have this. And this limit, and by the way, we have to do the absolute value of the general term. So we have, we're going to have an absolute value here because we have that negative sign lurking from the numerator at us, and we're going to find this limit, and it's going to be the absolute value of -6/4, which is 3/2. So it being greater than 1 means that the original series diverges by the root test. We have a series given to us by a pattern. I'm just going to summarize the pattern here. It looks like we have 6n plus 6 over 6n plus 5 to the power n. And normally we would try to identify this as geometric or p-series, and then set up the divergence test. In this case, I have a feeling that, well, actually, I'm not sure if divergence test here will be conclusive, but, well, yeah, no, definitely divergence test will work here. Because what's inside goes to 1, and 1 to any power is definitely not equal to 0. So we know this series diverges, right? But so we would have said, hey, it diverges by the divergence test. But we're not asked to determine the divergence or convergence. We're asked to apply the root test. So to apply the root test, we're going to set up this limit as n goes to infinity of nth root of the absolute value of the nth term. Now here everything is positive, so we don't need the absolute value. So we end up with something like this. I don't know why I keep putting plus 5 in the numerator. It's plus 6, and this limit is equal to 1. So the test is inconclusive. But we do know that the series diverges. So to answer this question, we're going to choose this option, but technically this is also correct. All right, we have another one. And we have normally we would again check if it's geometric or p, which it isn't. Then we would try to set up the divergence test by finding this limit. And I have a feeling that the divergence test may not be conclusive here. So when it's hard to find this limit, we bypass this, and now we are asked to do the root test. Normally it may not be your first choice, but here we are asked to do the root test. So we're going to set up the limit as n goes to infinity, and we're taking the nth root of 1 minus 3 over n to the power n squared. Taking the nth root is the same as dividing the power by n. So we have this. And now using that little cool thing, cool pattern from Newton, from one of the early exercises, we can conclude that this whole limit is equal to e to the power -3. And that is less than 1, because it is the same as 1 over e to the power 3, which is now definitely less than 1. So we would say that this series converges absolutely. But for positive, or rather for series with only positive terms, absolute convergence is the same as regular convergence. So the answer is converges absolutely here. And we finished the homework. If you have any questions, please let me know.